rid of that one to the left, right? Because that's what you do. That's why you do it again, right? To eliminate this one. So now this one could be eliminated, and now you could bring down this one. So here you have 1, 1, 0, 1. So it's all 4 zeros, right? So now you can bring down these things. So now you have again a situation like this: 0, 1, 1, 0, 1, 1, 0, 1. So this is going to be 1, 1, 0, 1. Okay? So again redo this. So 1, 1, 0, 1 is going to be 0, 1, 1, and skip that 0. So now you can bring down this 0, which I do here. So you have 1, 0, then this 0, which is 1, 1, 0, 1. So this is 1, 1, 0, 1. So this is just 1 and 3 zeros. So now these two zeros will make it up as the CRC. So let's say suppose if this was the end, you had just a 0. So this would be what you will end up with. And you know it's going to be 3 bits CRC because it started with 4 bits for generator polynomial. So then you have to just prefix a 0 and say this is the CRC, 0, 1, 0. Okay? Is that clear? You can also work out the problems that I have in the question bank.
Can you come back to that slide? Those numbers on the top of the line?
I had it before. It's not really of significance to compute the CRC. The numbers on the top actually mean something like this. Let's say you had 1, 0, 1, 1, and you had 1, 1, 0, 1, right? So you write them up. So you could fit 4 bits here and do an addition and do an XOR division or XOR arithmetic. If that can be done, you write 1. Okay? And then you get this 1, 1, 0, right? So you pull down 1 bit, right? And you could fit now 4 bits. So then you write 1. And then you have, say, this one, and then you pull down 1 bit, 1 bit. So for every bit you pull down, you cannot proceed further, right? So you write 2 zeros. Then, because you have this one already, you pull down this one, you cannot fit with this 4 bits. So you write a 0. You pull down this 0, you cannot still fit with 4 bits. So you put another 0. You pull down this one, now you can fit with 4 bits. So you put a 1 here. So now you get all leading zeros, so skip them. Now you pull down this one, you cannot match with 4 bits. So you put a 0. Then you pull down this one, you cannot match, so this is 0. Then this 0 still you cannot match, so third 0. Now this 0 you put match, so now you put 1. And then you have 1, and then these two zeros you cannot match, so you put 0, 0. So it's really to keep track of the process. Okay, but you did not write that. You can just do like what I did there. Okay? So now let's do some kind of analysis. What happens if some portion of a message is lost, okay, during transmission? And the lost segment is actually some portion in the error detection code. Now you have to also know this. You probably saw the structure of a frame before, right? It has a header, right, with the MAC addresses or things like that, and then the data portion. And then I said there's a trailer, which is like a 4-byte value, right? It could be like this checksum, which is like 16 bits. Okay? Now we also have what is called a frame delimiter, separating 2 frames. Because when you look on the channel, I think we did a problem on time division multiplexing. So you have 2 machines, let's say, and this is a channel. So when you put the frames one after the other on the channel, they are just binary sequence, 1, 0, 0, and so on. So if when the receiver gets them, or some machine that gets them, should be able to differentiate one sequence, one frame from the other based on the binary values, right? So in order to do that, we put what is called a frame delimiter which is like something 0 followed by 6 ones and a 0. Okay, so this is like a frame delimiter. Of course, this could be part of the data packet. We do some stuffing in order to get around the situation. We won't see all those things. But what we have to just know is we have frame delimiter, a beginning delimiter and an ending delimiter. Okay, separating one frame from the other. So this is one frame, starting from the header all the way to checksum, and it has a beginning ending delimiter. So the subsequent frame will be having another beginning and ending delimiter. So this is the beginning delimiter, and then the frame, and then the ending delimiter for this frame. So let's say frame 1, and then the beginning delimiter, then frame 2, and then the ending delimiter for frame 2, and so on. So this is how you have frames transmitted. Okay? So during transmission, let's say again took a security attack, the attacker removes or manages to remove 1/2 of the checksum. So the checksum is 16 bits. So he removes say 8 bits of the checksum. Why 8 bits? Because he wants to confuse the receiver with the delimiter. The delimiter is also 8 bits long. Each delimiter is 8 bits long, or 1 byte. Okay? So when he removes say 1/2 of the checksum, the receiver gets only 8-bit checksum. So when the receiver gets this frame, it considers, because everything is in binary, zeros and ones, right? So the receiver may think the checksum that it sees is actually a combination. So look like this. Let me break it out. Okay. Let me do it here. So we are more interested in the checksum here, the beginning delimiter, and then you have the actual frame. Then you get an 8-bit value of the checksum, and then this 8-bit, the ending delimiter, which is also 8 bits. So this is what the receiver sees as part of a frame. A beginning delimiter, then the frame contents, the checksum, which is only 8 bits now because 1/2 of it is lost, and then ending delimiter. And then you have, so this is the first frame, and then you have the beginning delimiter of this second frame, the rest of the frame. This frame may not be corrupted, just this particular frame is corrupted like this. This everything is fine. This is the ending delimiter, and so on. So everything else is fine. So just one frame, 1/2 of the checksum is removed. Okay? So now its receiver gets things like this, when in terms of trying to figure out what is going on, it sees a beginning delimiter and then the sequence of bits which it considers a frame, and then it knows the size of each component. The header size is fixed, the checksum size is fixed, and everything. So when it sees this following the data, it may think this as a 16-bit checksum because it's just a sequence of zeros and ones. So it may think this as a 16-bit checksum. And also what happens is normally the two delimiters are also the same. So the beginning delimiter will be the same, will be this, and the ending delimiter will also be this. So the delimiters that you use for both the beginning and ending is the same. So you may think this as the ending delimiter of the first frame. Okay, so this will be considered as the ending delimiter of the first frame. And this is actually considered some junk because after the ending delimiter of the first frame, there should be a beginning delimiter for the second frame. So it considers this as some noise on the channel and considers this as the beginning delimiter of the second frame. And the beginning delimiter of the third frame is considered as the ending delimiter of the second frame. So there's nothing like message here actually. So same thing will happen for subsequent frames because the ending delimiter of that will be the beginning and so on. So it's like a cascading effect or a domino effect. One frame is affected, subsequent frames are also affected. Okay? So again, this could be done only as a security attack. Okay, no natural factor is more likely to remove 8 bits when you have a lightning or so. So if an attacker manages to remove 8 bits from this checksum portion, then you could have some domino effect like this. Okay? Clear? So if you go through this, this is something important you have to know. So now we'll go to the last topic in this module, which is flow control. So what we mean by flow control is, again here we are looking at just point-to-point channels, which means a machine directly connected to another machine.